f of x equals 5x squared minus 3x plus 2 on the interval 0 to 2. And we have to find all numbers of c that satisfy the conclusion of the mean value theorem.
Yes. Very good. So what we have to do first of all is find f of 0, which we know is 2. We have to find f of 2, which is 20 minus 6 plus 2. I think it's 16. Then we have to find f prime, which is 10x minus 3. Okay, number 1. F continuous on the interval 0, 2 as a Pauli function. Number 2, f differentiable on the interval 0, 2 for the same reason. Therefore, there exists c in the open interval 0, 2 such that f prime of c equals f of 2 minus f of 0 divided by 2 minus 0. Is this okay so far? Okay, so I have to plug in 10c minus 3, and this is 16 minus 2 over 2. So 10c minus 3 will be 14 divided by 2, which is 7. And 10c equals 10, so c equals 1. And it must be in the interval 0, 2. And it's guaranteed by the mean value theorem to be between 0 and 1.
I always thought you plug that in for c.
C in f prime.
Yeah, I thought you put like 16 minus 2 divided by 2 as c, not set equal to the equation. That's what I was going on.
Yeah, because the two slopes are the same. Remember, we started with a line segment passing through those points A, B, and we found the a parallel that touches the graph at one point. So that's why this y2 minus y1 equals x2 over x2 minus x1 must equal f prime at that point. So the mean value theorem is done. So let me list some topics. So of course, critical numbers would be a question. Of course, the mean value theorem that we just looked at would be a question. Of course, the absolute max min on a closed interval. Of course, optimization. Newton's method. L'Hopital's limits. And graph. This is pretty much the entire test. Oh yes, and slant asymptotes. So critical numbers, mean value theorem, absolute max min on a closed interval, optimization, Newton's method, slant asymptotes, and L'Hopital's rule. And reading from some graphs. This is it. So what would you like to start with? Yes?
Can we do slant asymptotes?
Yes. So let's take a look. Slant asymptotes are on page on page 318. Let's say 64. We're given 5x to the fourth plus x squared plus x divided by x cubed minus x squared plus 2. So the first question here is, does this function have a slant asymptote? And first I have to say the function is a rational function. It has degree what at the top?
4.
It has degree what at the bottom?
3.
Yes. Because the degree at the top is exactly by 1 unit higher than the degree of the denominator, the quotient is aligned. As long as the quotient is aligned, this function has a slant asymptote. If it has a slant asymptote, it cannot have horizontal. So this type of function does not have a horizontal, it has a slant. May it have vertical? Yes, of course, there is no connection. But it would have a slant. As long as the quotient is a line, linear quotient. Degree 4 over degree 3, I would get a line. Degree 10 divided by degree 9, I would get a line. So all I have to do is make sure it's arranged in the correct order and just divide. 5x to the fourth blank x squared plus x blank. So x cubed minus x squared plus 2. I see that the degree at the top is indeed 4, but it's missing degree 3, and it's missing degree 0, which is okay because it's at the end. So now make sure that the quotient is a linear function. So x cubed times what is 5x fourth? 5x to the fourth. Yes, right? 5x, right? Good. So 5x times x cubed is 5x to the fourth. 5x times negative x squared is negative 5x cubed. And I cannot put it under anything that I have above because I don't have a like term with x cubed. So then the next and final question is plus 5. I bring down 5x cubed, of course, and plus x squared. Sorry about that. So 5 times x cubed is 5x cubed. Subtract.
Why didn't we distribute to 2 with like 5x?
Oh, my mind is not here. I talk too much. So plus 10x minus 10x. Minus 10x. Don't trust me tonight. I already told you, you've been warned. So after this, I will not trust myself tonight. I just didn't look. No excuses, no excuses. Okay, and minus 9x. Now let me start from scratch because I want to make sure what I'm doing here. So that's okay, and that's negative, yes, correct. Positive 10, negative 10. This is okay, and this is okay. Now positive 5, negative 5. It doesn't make any difference, but this is not the point. I need to correctly identify everything here. So positive, negative, negative, positive 5x squared, and positive 10, negative 10. So 6x squared minus 9x and minus 10. So the answer is, as expected, a line, but plus 6x squared minus 9x minus 10 divided by x cubed minus x squared plus 2. Thank you. My apologies, of course. Sorry about that. I was focused on the 5x plus 5 and I was done, but that's beyond the point. Okay, so then y equals 5x plus 5 is the slant asymptote. And please remember, the function has to follow it. It has a positive leading coefficient, which looks like this, which means that the end behavior of the function has to be this. Yes, Eddie, did I do something else?
Wouldn't it be negative 5? X minus 5.
No, because I asked myself, what times x cubed is positive? So at the top I don't lie. So what times x cubed is positive 5x cubed? And the answer is 5.
Oh, okay, yeah.
Then when I go back, I change, and I get negative 5x cubed. We can always check. How would I check? I would multiply this by this and add that. If I don't get the numerator, then the answer is incorrect. Would you like to do that, or is it clear that's okay? You want to? You want to check?
No, I see what you did.
Okay, so then one more time, the slant asymptote is a line with a positive slope. Then this is the end behavior of the function, because that's what the meaning of an asymptote is. The function has to follow it. Okay? So the end behavior will be negative infinity to positive infinity in case we're asked to graph. No. We're not going to graph that. The question was, does it have a slant asymptote? Yes. Determine it, if that's the case. Thank you. Good. Okay, so that's crossed off. Fine. Anything else? What would you like to continue with then?
The maximum,
You mean optimization or the absolute max min?
the absolute maximum.
Okay, very good. So let's take a look. Those are, I think they come from section 4.1. Okay, so let's take a look at, no, not a trig one. Oh, yeah. This is 59. So on that form, Han, is that correct? I think I remember this as x e to negative x squared over 8 on the interval negative 1, 4, right? Is that the first one? Okay. Did we do this one before?
No, we did it.
Okay, so this one is from the handout. Okay, so here we're asked to determine the absolute max min, local max and local min I'd like to add on the closed interval, 1 comma, negative 1 comma 4. So how do we start? Yes. Ready?
Yeah, it's derivative.
The derivative, yes. What I recommend is f prime and f of x and negative 1, 4. This is extremely important. That is the table that we have to present the information in. So then we start with the first derivative. Very good. So f prime of x. I ran out of paper, so I hope this is good enough. It's not my fault. He's right here sitting in front. And then I switched to green. Okay, so f prime. It's a product. The first function prime is 1 times e to negative x squared over 8 plus x times the second function prime, e to negative x squared over 8 multiplied by, can anyone tell us what? Multiplied by what? Exactly. Or negative x over 4, you're correct, or negative 2x over 8, that's fine. Yes, perfect. What do you think I'm going to do next? Immediately. Yeah, e to negative x squared over 8. Out. That's a problem. Good. So then I have 1 minus what?
X squared over 4.
Yes. Or e to negative x squared over 8, 4 minus x squared over 4. Finding the least common denominator. And then pulling out a negative 1. E to x negative x squared over 8 over 4. And x plus 2, x minus 2. If you want, you can change this into negative x plus 2, x minus 2 divided by 4 e to x squared over 8. Because it will be painful if I see that e to negative x squared over 8 could be 0. Because it can't, right?
Why is it over 4? One step back.
Because 2 over 8 is 1 over 4.
I mean, like negative e to the negative x over 4. So like,
Yeah, so I have to find the least common denominator. So I have 4 minus x squared over 4. And then I put this in here for this and pull out a negative because I don't care for these. Because the e to negative goes to the denominator. So I need critical numbers. And this function has 2. What are they? Yes. However, look at the domain that was given to us. -2 doesn't belong here. So it's only 2. So now I have to study the sign of the derivative. And I don't want you to waste your time. Obviously, when I study the sign of the derivative, I will not even consider this. Why? Why don't I consider this when I study the sign? It's always positive indeed. So if I plug in 0, I get positive. Of course, when I plug in 4, I get negative. And let me explain why. Let me explain why. Because the sign is given by negative x squared plus 4, correct? Negative x squared plus 4 looks like this. Just picture the graph in order for us to determine the sign quickly. So picture the graph. This is negative x squared plus 4. So in between solutions must be positive. Outside must be negative. So it's slightly confusing because -2 is not here. But between -2 and 2 is above. Outside is below. Okay, so then at this point, in the function, I will determine these points. These y values, I should say, to be correct. Okay, so let's determine the y values. So let's plug in the function in y equals. We had x e2 in parentheses negative x squared divided by 8. And now I want second table. And I want -1. I want 2. And I want 4. So -0.9, at 2, 1.2, and at 4, 0.54. 0.54, yeah. Okay. So now I have to make sure that the two lines, what rows, the f prime and f work together. From -0.9 to 1.2, yes. True. From 1.2 to 0.54, yes. So obviously, this must be the absolute min. This must be the absolute max, and also local. And this is nothing. Because the value of 1.21 is the maximum, the value of -0.9 is the minimum. The endpoints cannot be local. Is this okay? Okay. So next question. Say it again.
I have a random question. I saw.
You want me to? Yeah.
It was like, how small can f of 9 be if f of 4 is equal?
Yeah. Let me write it. Let me write it. We had something like that in class, but let's do it.
So it was, how small can f of 9 be if f of 4 is equal to 9 and f prime of x is greater than or equal to 1 or on the interval 4 to 9. So 4 is less than or equal to x.
So it's greater than 0, you mean?
Well, it's like 4 less than or equal to x.
Yeah, but f prime is what? I didn't catch that. I'm sorry.
Oh yeah, that's right.
F prime of x is greater than 1?
Mm-hmm.
Okay, if?
4, because 4 is greater than or equal to x, is greater than or equal to 9. Yeah, 4 and 9.
Okay. So, we are asked to determine, or to have some idea about f of 9. How small? Or how big?
How small?
How small, okay. How small can f of 9 be, knowing that f of 4 is 9, and knowing that the derivative is greater than or equal to 1 for any value of x between 4 and 9. Am I correct? Okay. So then this means that we are looking at the closed interval 4, 9. And I'm assuming that the function is continuous and differentiable. Did they?
I think it's-
Right, because it says f prime of, yes. So definitely it has to be differentiable and obviously continuous, because we are told that f prime of x exists, if it's greater than or equal to 1, exists for any point between 4 and 9. So these are typical conditions for which theorem?
mean value.
Of course. So that alone signifies continuity and differentiability of this function on the given interval. So therefore, there must exist a c between 4 and 9 such that f prime of c equals f of 9 minus f of 4 over 9 minus 4. Because the function that we're given fulfills the two requirements of the mean value theorem, continuous and differentiable. You can say, but you know differentiable, well, you know continuous. Of course, right? Because if the function is differentiable, it must be continuous. We know that. But if it is continuous, will it automatically be differentiable? No, because you can have corners, you can have cusps, right, or vertical tangents. But if it's differentiable, I know it must be continuous on that interval. Outside of that interval, I don't know, but on that interval for sure. Okay, so then I know that f prime of x, including f prime of c, everywhere, because c is between 4 and 9. So f prime of x is greater than 1, so is f prime of c, so that is greater than or equal to 1. Because it's for a c in the interval. And that is guaranteed for any c or any x between 4 and 9. So therefore, f of 9 minus f of 4 over 5 must be greater than or equal to 1. Would you agree so far? It's a very good problem. I should have put this on the test. Okay. So, but I know what f of 4 is. It's given to us. So then f of 9 minus 9, multiply both sides by 5, greater than or equal to 5. So then f of 9 greater than or equal to 14. So now I know that the minimum possible f of 9 for this scenario must be 14. So only because I knew that the two given conditions, right, continuity and differentiability, they must. Okay, very good problem. Thank you. Okay, so we looked at these and the mean value theorem and critical numbers. Okay, do we need Newton's method, or are we okay with Newton's method?
Could we review on this?
Yes, yes. Would you like to choose a problem, or do you want me to choose a problem? Okay, any problem. Very good. At the review, at the end of chapter 4, 62, page 353, sine x equals x squared minus 3x plus 1. 6 decimal places. So we're given an equation. No one can solve this by hand. There's no algebraic method. That's what I mean by solving it by hand. So what is the first step? We want to use Newton's method. What would be our first step here? Say again? Right, create the function. That's our first step. So sine x minus x squared plus 3x minus 1 equals 0. And this is our f of x. And it is a continuous function. Definitely, because I should put that in writing. It's continuous. It's a difference in the sum of continuous functions. Okay, now I have to put this function in the graphing calculator and find a 1 unit interval where it changes sign, either from negative to positive or from positive to negative, so that I can start the algorithm, the Newton's method. So let's do that. in y equals, clear. And now we have sine x. Be careful, I worked with my pre-calc class, and just make sure that the mode is in radian. So I don't remember if the last thing I did with them was in radians or not, so I have to check. So make sure it's in radians. Okay, so in y equals, we have sine x, close the parenthesis, minus x squared, and plus 3x minus 1. Okay, then go to second and table, and punch in, I don't know, 0, 1. Good enough. I don't care for anything else. So the interval is -1, 0. I'm sorry, 0, 0, 1. Sorry. The interval is 0, 1 because at f of 0 the function is negative, and f of 1 the function is positive. So a continuous function that changes sign on the interval 0, 1 by the intermediate value theorem guarantees a c for which f of c is 0. So these three conditions, continuous and changes sign, by the intermediate value theorem, there exists a c in the open interval 0, 1 such that f of c is 0. In other words, there is a solution. In other words, there is an x-intercept. In other words, the function must cross the x-axis between 0 and 1. It must. It's continuous. It's negative at 0 and it's positive at 1. Is that clear? Okay. So then, and now I create Newton's method, or the function. Do not delete what you have in y equals. So I like to call it n of x. You don't have to call it anything if you don't want to. So I call it n of x, Newton of x, minus the function at the top, sine x minus x squared plus 3x minus 1, and the derivative in the denominator, cosine x minus 2x plus 3. Now we have to make a decision. Where do we start? We want to start at 0 or we want to start at 1. It doesn't matter. As long as the denominator of the Newton's method of this function is not 0. If you start at 0 and the denominator is 0, you can proceed. If you start at 1 and the denominator is 0, you can proceed. So when I plug in 0, cosine is 1, so 1 plus 3 is not 0. So I can start at 0. If I start at 1, this is 1 plus whatever. It's not going to be 0. It's not going to be -1. Cosine 1 radian, it's not 1. It's not -1, so we're fine. Regardless of where we start. Either at 0 or 1, it doesn't matter. Yes, hon?
In the test, do we have to write all the
Yes.
answers?
Yes,
leading
please.
up to- Okay.
Yes. Yes. Because I check. Yes. Please. So I'm going to write them now as I would like them to see them on the test. So have you made up your mind? Where is the starting point? You want to start at 0? Very good. So now let's go to the calculator. Do not delete what you have because we are going to use what it's in there. So just press insert, second and insert. And then we put in x and minus and the left parenthesis. So x minus the left parenthesis, everything in parentheses at the top. So go to the end. So much easier for you than for me here. Okay, close the parenthesis and divide in parentheses by cosine x minus 2x plus 3. And close the parenthesis. And now, are we ready? Eddie, is this okay? Now we have to get out of there with second and quit. Second and quit, get out of there. Second and quit. And then we go to variables. So the next step, we go to variables. Are you okay, everyone?
Mhm.
Yes? Okay, go to Y variables, to the right one. Select a function, yes, and select Y1. If your function is in Y1, you may have something that you like to save in there, and you are in Y3, then you select Y3. Whatever where the function you have, the function that you just put in. So now in parentheses we put 0 and close the parenthesis. And this will be our first iteration. Now be careful with one thing. So I'm expecting an answer between 0 and 1. This is good. I'm expecting somewhere between 0 and 1. But if the answers will be all over the place, like -3 and then +4 and then -5 and then +1, you know something is terribly wrong. It's either the mode should be in degrees instead of radians or vice versa. Okay, so be careful. So we're on the right track. So now I copy what I see with second and entry, but I will override the 0 by the previous answer. I don't want the function to be evaluated again at 0. I want the function y1 to be evaluated at this answer now. Yes, right?
On the test, can we do y1 in parentheses answer and then write the answer next to it?
So this is what I'm going to show you what I expect you to write. Here it is.
All right.
So x0 is 0, x1 is 0.25, and x2 is coming up right now.
Gotcha.
So when I click enter, then I have 0.2687655. And then I continue, I copy what I see. Nothing else, I don't do anything. So then I have x3, which is 0.268888134. And I'm hoping that I don't have to copy the next one, because it's quite close. Yay, I don't have to copy the next one. So with 6 decimal places, because they repeat already, 1, 2, 3, 4, 5, 6, 7, 8 already repeat. The solution is 0.268881. So I didn't have to copy the next. So this is the solution. And the method basically converged in 3 steps. Why I didn't copy the next one is because all these digits were repeating. So there's no need to copy the next one. Although the next one is a better approximation, but we decided to stop at 6 decimal places. Okay. So this was Newton's method. We're postponing the inevitable. Yes, can I look at, do we have anything here? Okay, so this was Newton's method. What about optimization? What about a graph?
Optimization.
Optimization, can I just copy it and I'll do it back here. So please redo the problems we did in class. Okay?
Is that in?
Yes, because I picked one. Yes. So 1,200 centimeter squares of material is available to make a box with a square base. And an open top to find the largest possible volume or max volume. Thanks, sorry about that. And you don't know, I made at least 5 extra copies, and now I don't have any. Okay, so the surface area of the box is 1,200 square centimeters, and we want to determine the dimensions of the box, knowing that the base is a square. So we want to determine the side of the square and the height. Okay, so let's think how we do this. In order to find the maximum of a function, I have to determine what?
The derivative.
The function, right? In order to find its maximum and find the derivative, I cannot find the derivative if I don't have the function. So can anyone give us the volume of this?
X squared each.
Good. Can anyone now give us the surface area, which is the material used, the area of the material used to create the box?
X squared plus 4xh.
Very good. Thank you very much. The base, which is x squared, it has an open top, and there are four sides that are equal in area, base times height. So x times h, x times h, x times h 4 times. So this has to equal 1200 squared centimeters. So I'm happy that I have a function that represents the volume. However, it has two variables, so I need to get rid of one of them. Which one will you eliminate? Which one will you get rid of? Yes, of course. Of course. I can solve this for x. My only chance is to solve for h. So 1200 minus x squared, and then h equals 1200 over 4x minus x squared over 4x. Yes, I will simplify a little bit. And then replace it in here and distribute x squared. Is everyone with me so far? Yes? So then h, I'll simplify and I get 300 divided by x minus x over 4. And this is what I plug in the volume. Everything okay so far?
How did we get the 300 over x?
I simplified by 4. 4 divided by 4 and 1200 divided by 4
Oh,
to simplify it as much as possible. And I took it away an x and an x.
gotcha.
And now I plug it in. And now I can say that this function is indeed a function of x only, multiplied by x squared. So x squared times 300 over x minus x squared times x over 4. This becomes 300x minus x cubed over 4. So I simplify it again, an x with an x, so I got 300x, and then I had x cubed over 4. Okay, so now we're happy. We have the function. It's a function of one variable. That's nice. What do I need to do next? Right, thank you. V prime of x equals 300 minus 3x squared over 4. Okay, I have the function, I have the derivative, now what? What am I looking for next? They are called critical numbers. Yes, so 1200 minus 3x squared divided by 4 equals 0. Or negative 3x squared plus 1200 equals 0. Or x squared equals 400, very nice. I will not put plus or minus, oops. I will not put plus or minus. And this is centimeters. So this is a critical number. It doesn't mean anything before I study the sign of the derivative next to it, left and right. It could be a max, it could be a min, I have no idea. And we had that happening, right? Remember last time when we looked at it? It was not what we expected.
Yep.
So then, x, 0 and 20, v prime, and the function. So here is v prime, or this one, because I didn't change anything. So when I plug in 0, I get positive. When I plug in 100, I get negative. So this is typical for a max. So now it's guaranteed. If in case we're asked to find the maximum, we will have to plug in 20 in the volume. But for now, we know that this would be the setup for a maximum because the first derivative is positive and then negative. We are also asked to determine h. We're asked to find the length and the side, the measure of the side of the square and the height, of course. So where is my height? Okay, here it is. So 300 over 20. That's 6. I'm sorry, 15. Don't trust me tonight, I'm telling you. So 20 over 4 is minus 5, so this is 10 centimeters. So the square of the side of the square is 20, and the height is 10 for a maximum volume for this box. Okay, any questions on this? Is this okay? Yes, please. No?
Can we break down, I know it's a silly question, but how you get the surface area of the box, so it's side to side,
Yeah.
and where the x squared come from? That's
Okay.
time to put.
So assuming that this is a square,
Uh-huh.
the base is a square, so x times x is x squared.
So that's the base.
Yes, and then
And plus the four
all these four are the same. Is that okay?
Open, okay, never mind.
Yes, because it says open box. Okay, so this was an example optimization. What I didn't write here is graph. Oh, I did. So we have L'Hopital's rule or limits with L'Hopital's rule and graph. Okay, what is our next step? What would you like?
Don't we have to plug those numbers back in to get the volume?
Are we asked to find volume?
The largest volume.
We are okay, very good. Sorry about that. So here it is. Here is the volume. So the volume of 20 will be 300 times 20 minus 20 cubed divided by 4. Or you can go back to the one with, that's even better and easier, the one with the volume, which is x squared h. So this is 400, that's even better, times 10, 4,000. I didn't need to go back to the volume with x alone because it's the same thing. Even if I use that or I use x squared times h, it's the same thing. Good. So what are we continuing with?
Graph.
Okay. Do I get to choose or you want to choose? Oh, you can choose. We can choose that. What was it? 2 the square root of x?
Yeah, minus x.
Okay. So please redo your quizzes. We had one quiz with a hole in the graph, so please also refresh your memory on that. We know the slant asymptote, so okay, so very good. I have to find the domain of this function. Can anyone give us the domain of this function?
0 to infinity.
Excellent. Thank you, hon. So indeed, the square root does not exist. It's not a real number if the quantity under the square root, right? We talked about that. It's an even root. The quantity underneath has to be 0 to infinity, between 0 and infinity. Good. So now we have to start by determining the x and y-intercepts and the limits. So here there is no limit. When I plug in 0, what do I get?
0.
Perfect. What about the limit? Careful here. Which of these two quantities is the most powerful one?
X.
Right. The square root of x or 2 the square root of x don't count. That quantity does not count when we talk about infinity. This one is the one that dictates. So then, when x approaches infinity, where does the function go?
Negative.
Right, because this is too small to mention. So this is indeed negative infinity. Good. So now I need to determine the x and y-intercepts. I already have determined the y-intercept, but there may be other x-intercepts. So how do I determine the x-intercepts for any function, including this one? I said? Very good. So I have 2 the square root of x minus x equals 0. Careful with this, because this is a radical equation. how do I solve a radical equation? What should I do to both sides to solve this?
Square.
Yes, I have to square. So then I have 4x equals x squared, or x squared minus 4x equals 0, or x minus 4, or x equals 0, and x equals 4. I already had the 0. I just need to put the 4 in. Now, we exhausted all the information that comes from the function, about the function. So now we have to determine the derivative. Set it equal to 0 to find critical numbers, and then study its sign. Are we ready for that? So then f prime is 2, 1 over 2 the square root of x minus 1. So then 1 minus the square root of x over the square root of x. I see two potential critical numbers here. Can anyone give us those potential critical numbers?
You can rule out 0 because it's an endpoint on the
It is a critical number, however, because the derivative is undefined, but the function exists at that point. If the function doesn't, then that is not a critical number. But because f prime is undefined where the function is defined, which means x equals 0 is a critical number. If the first derivative doesn't exist there, the second one, of course, will not. Okay, so now what is the other number that is the critical number? And you should write 1 minus the square root of x equals 0. Change this into the square root of x equals 1 square again and get x equals 1. There is one thing that I did not say, and I should have. Every time we square both sides or raise both sides to a power, we have to check the solutions. It's okay, it works, but I should have said that. So the square root of 4 is 2, 2 times 2 is 4, 4 minus 4 is 0. So both solutions work. Same thing here, with x equals 1. Yes, 1 minus 1 is, yes.
How do we get the 1 minus square root of x?
So I find the least common denominator. That's okay. 1 minus the square root of x over the square root of x. So the numerator has to be 0, or a fraction to be 0. Yeah.
Why do you say 0 is a critical number?
Because the function is defined at 0, but the derivative is not. So it's a cusp. The derivative, so the function is not differentiable there, but it can be a local, it can be an absolute min, and it will be an absolute min, or not. But it could be something important. I haven't looked at it. But yes, so it's a critical number. It doesn't necessarily mean that it's going to turn into a max min, but it's a critical number. Remember, critical numbers come from two possible sources. Either f prime being undefined where the function is defined, or when f prime is 0. Are we okay with that? Okay, so now let's study the sign. So here's the derivative. I don't care for this. I'm not going to plug in anything in here. How come? Because it's positive, right? But I'm going to plug in, let's say, 1. Oh, I have to put 1 in there, sorry. So let's say I'm going to plug in 0.5. When I plug in 0.5, it's positive. When I plug in 4, it's negative. Critical numbers have to be. I started and then I got sidetracked. Sorry about that. So now I have to find the y value at 1. But not a big deal, because at 1, what do I get? 1. Now at this point, I make sure that these two work well together, because if they don't, I have to go back to the drawing board. From 0 to 1, is it up? Goes up? Yes. From 1 to 0, is it going down? Yes, and that's supported by n0 to negative infinite. And now finally we want to look at the second derivative. I will not use the fraction, I will use this to differentiate, right? So the derivative now is x to negative 1/2. Of course, minus 1. But when I differentiate, I get negative 1/2 times x to negative 1 minus 1, which is negative 3/2, or negative 1 over 2 the square root of x cubed. What type of number is this? Because we don't want to waste our time. Remember, x is greater than 0. So what type of number is this?
Is that one of your asymptotes?
No, this is the second derivative. No, none, because it's not 0. So what is the sign of this, no matter what? Remember? Yes. So if it's always negative, we're done. And you can say, what about symmetry? There is no discussion of symmetry here because the function is defined from 0 to infinity. It cannot be symmetric no matter what, with respect to the y-axis or the origin, if it exists only on the side. So there is no symmetry here. So now we are ready to graph it. Yes? I plot the points I have, and I have 0, 0. I have 1, 1, 2, 3, 4, 0. So the function is increasing from 0, 0 to the local max, which happen to be global as well, to this point, opening down all the time and now decreasing, crossing at 4, 0, and going to negative infinity. And this is it. And this is f of x to the square root of x minus x. Okay, so we also looked at graphs. What about L'Hopital's rule? And then I have a few other questions to look at with you. Yes, please, Eddie.
Yeah, it wasn't in this question, but for a graph, when a whole is when you can take away the numerator and the
Yes.
denominator.
So yes, it has to be normally. I shouldn't say has to be, but in these cases are rational functions, and you have to state the domain before you simplify. And if a factor goes away with a factor from the top, that is no longer a vertical asymptote, but it's a hole in the graph. Yes. The vertical asymptote is there only if the factor stays after the simplification process is done.
And if we had a fraction, we would, if the degree was 1 higher up top, that's what we would need to find this thing.
The slant asymptote is only when the degree of the top is higher by 1 unit. Yes. Good. Anything else you would like to go back to?